Hello everyone. So this is the first video to introduce some of the features that the HL7 PET library offers. And we're going to be focusing on how that library can help you query information out of HL7 messages. The library is built to be fast and effective. So it doesn't try to parse the entire HL7 message into like a complex graph of objects trying to understand every single needy detail of it. Uh, on the other hand, it kind of relies on string parsing and regular expressions to find information out of HL7 messages. It doesn't matter which flavor of HL7 message you're using. It basically, if it's a well-formatted HL7 message, is where you have your segments and the fields are pipe delimited, your components and subcomponents, etc. This library should be able to extract information out of messages, out of HL7 messages. And the way it does that is by using a path. So similar to JSON paths or XML paths, we created a syntax to teach the library how to extract. So the path is basically you need to identify the segment you're extracting information from. That's basically the only required information from the path. With this, you already can interact with the library. I'll show that in a minute. Segments can be repeated segments, so sometimes you need to provide the index of this segment you want to interact with, or the segment you're interested in. Then you do a dash field where you specify the field that you're interested within that segment. And again, fields can be repeated, so we can provide an index for a field as well. When not provided, those indexes basically just default to any or all of them, like a star. So it will be basically a star. Fields can be divided into components, so you can provide a component, and components can be divided in subcomponents, so you can also be providing a subcomponent element to your path. So this is pretty much the entirety of a path, a HL7 path that you can provide. So let's look how that works. So back to this tool here that it's just a helper tool to show how the HL7 library can be used. This is not part of the library, but it was built using the library. So I generated a COVID lab report message using ChatGPT, some AI here, and it's just a basic example of what COVID-19 lab results could look like. So I'm gonna load this into this tool and then I'm gonna start interacting with it. So basically I can provide any path. So let's say I'm interested in the message header, the MSH, right? Which is this first one here. So if I request the MSH, as you can see, the entire MSH segment comes in. And the more specific I am, the less HL7 it will look like, right? So for now, because I only ask for a entire segment, I still see pipes and I still see the limiting and things like that, right? But let's say, okay, I want to know what's the version of this message that he generated. And usually MSH12 tells me the version, right? So MSH12, here's 2.3. And you can see here, if you count the fields here, this is a 12 field and the value is 2.3. If I want to know the type of message that I'm retrieving, which is usually on MSH9, you can see that's an ORU R01. This field here is a field that has multiple components, as we can see by the caret here. So I could ask for MSH91, or I could ask for MSH92. Now, one thing is the library will never give errors. So let's say, for example, I ask for MSH34, which we saw that 23 was 2.3, the field 12 was the last one. So there's no MSH34 on this message, but all it says is no results match. It doesn't give you errors or anything, it's just a best effort, right? The same with the ninth element. If I ask for 9.1, we saw these components, but I say 9.2, 9.3, there's no results. There's not a third component to that. So it's not erroring out, it's just telling you he couldn't find anything on MSH 9.3. So it's up to the user to understand your HL7 flavor and know where you want to extract information. And it's very lenient in the sense that you're never going to have to be handling errors if the information is not there. Most HL7 messages, a lot of fields are optionals or require empties and things like that. So we decided not to throw any errors when you provide a path that doesn't match. So let's talk about the indexes. So MSH is easy because there's only one per message. Again, this is pretty much saying MSH1, so I get the first MSH. If I were to say give me the second MSH, there's no such a thing, so no results match again. But if we get a segment that's repeated, like OBR here, we have 3 OBRs on this message, then I can start playing with the indexes, right? So I'm interested only on the OBR1. Oh, and just FYI, the asterisk I mentioned before, right? So OBR asterisk is the same as OBR. It's just a shortcut. But OBR1 retrieves me the first OBR, where the code is 1, 2, 3, 4, 5, 6. OBR2 is 1, 2, 3, 4, 5, 7. And OBR3 is 1, 2, 3, 4, 5, 8. Again, this index here is not the value on the OBR field number 2 here, 1. I even put like a 22 and 33 here instead of 2 and 3, because if I ask for OBR 22, even though the value here is 22, this does not match because there's not 22 OBRs to get the 22nd of it. So there's only 3 OBRs, and then you can retrieve that. So it's the index of the OBR according to in relation to the entire message. And again, I can be as specific as always. So I can say, give me the third OBR, but I'm only interested on field number 2, right? So I get only number 2, or field number 3, and then this is a field with components. So I can say field number 3.1, 3.2, etc. So everything works after the OBR as well. This also works with like retrieving OBXs. So I can get all the OBXs, and this message has a lot of OBXs, about 12 it seems. I didn't count them, but we noticed that there were 3 OBRs, right? And if I go here, this OBR here had 5 OBXs. This OBR here had another 3 OBXs. And this OBR here had another 4 OBXs. But there's no way for me here, like with the path that we learned so far, to say, give me the OBXs that belong to an OBR. And that's where this profile here comes in place. I skipped this on purpose, but now we're gonna handle it. HL7 on its own, it doesn't recognize parentage, parent-child relationships, or which segments belong to what segments, etc. Right? It's a very flat structure, and when it comes to this type of concepts that we are embedding on it, like we as human beings, we can see this, and we know that those OBXs, those observations belong to this OBR here. So to teach the HL7 parser about this hierarchy, we created some profiles. And for this tool here, I'm always loading a default profile, but you can create your very own profile depending on your needs, because every HL7 message might be different. You might have to handle hierarchy differently. So for that, I have the profile loaded here. So that's how this profile looks like. It's a JSON segment with basically 2 main areas: the segment definition and the segment fields. We're gonna skip the segment fields for now. We're gonna cover that on a future video. But what we're interested here is on the segment definition, because that's the one that gives me the parent-child relationship. And the way I define this default profile is I have a single root segment, which is MSH. So if I close this, that's the only segment that's root. But it has children, so the MSH can have like PID, SFT, and OBR segments as children. So those are the only possible children that it, in my small example here, could look like. On a real example, I will be defining a lot more segments, but for the sake of brevity and simplicity for understanding, I just provided those 3 here. We also provide the cardinality here, but again, it's not used for parsing or extraction of information per se. but we'll cover the cardinality in future videos as well for other features that the library offers. And so this is the first level, MSH is the root, PID is the second level with SFT and OBRs, and those can have children as well. So PID could have PV1, NK1, and node segments. So those are all defined as well, and those don't have children. The SFT has no children, is a single like leaf kind of segment. And the OBR, as we expected, could have OBXs, SPMs, and nodes, right? And the OBXs can have children as well, so nodes could be under OBX. SPM could have nodes as well. I could even go further and say OBXs, I've seen some examples that SPMs have their own observations. And then I'll define here as a children of SPM. And even though we have OBXs here and here, the tool knows how to handle that appropriately according to the order of those segments. But for the simplicity here, so SPM only has nodes, and nodes again. So nodes, so you can see it's under SPM, under OBX, we saw that under PID as well, and it's under OBR. So that's the basics of what is the profile looks like. And this profile is already loaded on our tool here. So if I want to know all the OBXs that belong to a specific OBR, so let's say I have this first OBR here, right? COVID-19. So let's say it's the OBR1 that I want, and then I want the children of that. So we use this dash arrow here to represent relationship. So from the OBR1, give me all the OBXs that you find. And now the list is only 5. So remember before, it was all the OBXs on the message, 12 of them. We can still retrieve them directly. We don't need to use parent-child relationship all the time. But when I'm interested, I can do OBR1 and give me all the OBXs for that OBR1. So then we see only 5 of them. And of course, I can still keep using, like if I'm interested on OBX3 for all of them, and I want the codes for all of those, so we can see all the codes associated with that OBR. If I were to bring OBR2, so I only see 3 elements here. So if I go to the OBR2 here, we have OBX 6, 7, and 8. So let's get that value now. So you can see 6, 7, and 8 are retrieved. And if I do the OBR3, I see 9, 10, 11, and 12. So 9, 10, 11, and 12, right? And again, I can bring other things as well. OBX12 doesn't exist, my typo. But here's the OBX2, the types of them, the OBX3, which questions were asked, 4, which has some information here, 5, here we go. So that's how you use the parent-child relationship. We also said SPMs are children of OBR, right? So you get us the SPM for 3. Of course, if I ask for all OBRs and give me all the SPMs OBRs, that's pretty much just saying give me all the SPMs, right? There's two more features I want to show. One is a shortcut. So sometimes I want the last OBR, right? Which in this case is OBR3. But if I want the last one, I will have to like give me all the OBRs, count how many of them, so I can know I can stick a 3 here as the index and retrieve that one. So as a shortcut, we can do last, and you get the same OBR33 as last. Of course, first is just the one, so no need to have a shortcut there. Now the second feature, and that's the last feature we're gonna show here, it's a lot more intense. You've seen that we've been hard coding 1, 2, or 3 here, but there's a way to dynamically provide a value to the index. So let's say I get my OBR1 and I get my OBXs, right? So here's all the codes, and sometimes those codes are known, and I need to know the value of the response for specific codes on those observations. At least on this example here, right? We have these observations here. The third element tells me what's the test applied, and the fifth element is going to tell me what's the result, right? But let's say I'm interested only on, say, the SARS-CoV-2 RNA here, right? So I can get the SARS-CoV-2 RNA or this code here. The code is more reliable usually, and I can say we could do that on a parent-child relationship as well, but I'm going to simplify here. And instead of passing OBR2, because I'm a human, I know that's the second one, the code doesn't, I'm going to use an @ sign saying I'm going to provide you an expression, and I want you to go on the OBX and find where 3.1 equals the code that we specified. And here we go. So he found that OBX, and here's the only OBX that has 94308-4, and then it brings the value. If I want to know the result of that, of course I could do -5, and okay, so for 94308-4, the result was positive. So that's how you use those indexes. There's many expressions we can provide there. The equal sign is the most common one because we are interested in very specific results. I see this one here is repeated, so let's use this one here. So you can see that it doesn't need to return just one, it could return multiple values as well, because I saw that being used on OBX9 and OBX11. So we retrieved both of them. And I think for this one was on 4 was 1, and this one was 2, and etc. So that's how you use the @ signs. I could use other things like OBR. Let's say we have codes of OBRs 1, 2, 3, 4, 5, 6, 7, and 8, right? So let's say I want all the OBRs where the second value is greater than 1, 2, 3, 4, 5, 6. And then I get OBR2 and OBR3 because this is 5.7 and 5.8, but the 5.6 is not greater than itself, so it stayed out. So you could use greater than, not equals to, etc., and things like that. Same of like the OBXs, they all are ordered properly, 1, 2, 3, 4, 5, 6, 7, all the way to 12. So I can say, give me all the OBXs where 1 is greater than 5. We always put it in quotes, the value, but here we go. So it started with 6, 7, 8, 9, 10, 11, 12. So those are some of the features of the path that we support, and more are coming as we progress developing this library, but I hope this can be very helpful for you in the time being. Thank you very much. Looking forward for the next video. Bye.